Hey guys, welcome back to the channel. So in this video, we'll talk about milk and milk products. So let's get started. So what are the components present in a milk? So milk is a complex fluid that contains a remarkable array of chemical components dispersed in an aqueous medium. And a whole cow's milk is approximately 88% water, 5% carbohydrate, 3.5% protein, and 3.5% lipids or fats. So these are the major components that are present in milk. On with this. So let's just talk about the lipid or the fat content first, and then we'll move to the other parts such as proteins and carbohydrates. So talking about lipids or fats, so the fat content in cows varies considerably from 3.3 to 3.7% fat. Although milk contains phospholipids, carotenoid pigments, sterols, and fat-soluble vitamins, and it is the milk fat that generates particular interest in food products. So it all contains the phospholipids, triglycerides in abundance. So moving on with this. So here you can see the fat content in different types of milk. So there are different types of fatty acids as you can see. So these are the saturated ones, unsaturated ones, and polyunsaturated ones. So the composition varies from the type of fatty acids. So the saturated ones contain 62.3% of total fat percentage, whereas the monounsaturated ones contain 28%, whereas the polyunsaturated ones contain 3.6%. So this is just a table for your reference with this. So talking about the next component, which is the carbohydrate. So a cup of milk contains around 11 to 12 gram of carbohydrate, almost all of which is in the form of lactose. So lactose is the form of carbohydrate that is present in the milk. Also this disaccharide, which is only about fifth or 1/5 as sweet as sucrose, is quite an uncommon carbohydrate, and it is not found in significant amounts in food and other than milk and milk containing products. So lactose is a disaccharide as we know. So it is present in the milk in the form of a carbohydrate, and it is not very sweet as sucrose. This. So there's another form of lactose, that is alactose, which is a less soluble form of lactose, and it's a disaccharide prominent in milk and a form of lactose largely responsible for the sandy texture of some ice creams. So sandy texture of ice creams, as we know, so those are mainly due to the presence of alactose. So this is another type of lactose as we see here. So talking about the next component, which is protein. So protein, as we know, so there are two types of protein that mainly forms the milk. So one is the casein protein and the second is the whey protein. So casein protein is present in around 80%, and the rest 20% is whey protein. So this. So talking about this, the composition of casein and whey protein, and what all casein protein includes and what all whey protein includes. So casein protein includes alpha casein, beta casein, which forms about 78% of total proteins. And it has an isoelectric point at 4.6, where it coagulates and form curd, or a sort of it coagulates and leaves out the whey protein. So I'll show you a picture where the milk will be reaching at an isoelectric point on the addition of some citric acid or any sort of acidic solution, so that the milk coagulates, and the rest we get the whey protein. So the whey protein percentage is around 17%, and which includes beta lactoglobulin, alpha lactoalbumin, immunoglobulins, serum albumins. So these are some of these. And moving on this, so talking about the protein content in detail now. So talk, as I said, about the isoelectric point and how the two proteins can be separated. So talking about the whey protein, which is present in a less quantity other than the casein. So it's a liquid that drains from the curd of clotted milk containing lactose, proteins, water soluble vitamins, and some minerals. So as we know, so whey is formed only when the milk coagulates. So how will the milk coagulate? So the milk coagulates only on the addition of some acidic component, which can be either citric acid. So on addition of citric acid to the milk coagulates, and the rest solution which is present in the milk, which is the whey. So the liquid that is present in the milk other than the milk component which coagulates. So let's say this is the coagulated milk which has been formed, and the rest liquid that is remaining here is the whey. So that is the liquid that is present in the milk. So that gets drained on the formation of curd. And a curd is a milk precipitate that contains casein and forms readily an acidic medium. So the coagulated milk is nothing but casein. So I have a picture to show. So before that, we'll get to this. We'll read this point, which is when the pH of milk is adjusted to 4.6. So the 4.6 is the isoelectric point where the milk coagulates. So the casein is quite insoluble and precipitates readily to form a soft curd. So if the casein protein coagulates and forms something known as soft curd. So this is a picture I wanted to show you. So casein protein can be precipitated and removed from the whey by addition of acid to shift the pH of milk closer to the isoelectric point. So on addition of citric acid, to this thing. So let's say this was milk. So this was the actual milk that was present here. On addition of milk, this is the condition that is formed. So when we add citric acid onto the milk, so this is what we see. So as you can see, two separated layers. So this is the coagulated protein or the coagulated milk, which is casein here. So this is the casein protein. The rest that we see, the watery fluid liquid, which is nothing but the other protein, which is whey protein. So this is whey and this is casein. All right. So this is what I wanted to show you. This happens when the milk is diluted or added with citric acid at a pH of about 4.6. So citric acid in general is acidic in nature. So an addition of an acid to the milk, the milk coagulates and it forms two different proteins. So this is a sketch of the gradual clumping of casein molecules to form a soft gel when rennin is present. So rennin is a calf protein, which is also acidic in nature. So if we add rennin or citric acid, so both are acidic in nature. So the casein molecules coagulate slowly. So this is the picture after 1 minute, and this is the picture after 4 minutes, and this is after 8 minutes. So these are small casein molecules which slowly coagulate. So these are small molecules. After some time, it combines with many small molecules to form a bigger molecule, and after some more time, these bigger molecules combine to form even bigger molecules. So these finally coagulate to form casein, and the rest fluid matter which is present is the whey. So talking about some of the enzymes now. So milk contains many enzymes including alkaline phosphatase, lipase, protease and xanthine oxidase. So the resistance to denaturation by heat varies with the enzyme. So definitely when we heat the milk for killing microorganisms, so some of the enzymes may get denatured. So it depends from enzymes to enzymes. So some of the enzymes like protease is quite resistant, and a fact that can create problems in some milk that is subjected to high temperature, short time heat treatment methods. So protease is a milk enzyme that is present in the milk that is very much heat resistant, and it does not get denatured on subject to high temperature. And there are many enzymes, as you can see, such as phosphatase, lipase and protease is present other than that. So talking about some of the vitamins and minerals. So milk naturally is an excellent source of riboflavin, calcium, phosphorus, and it also provides valuable amounts of thiamine, niacin and vitamin A. So these are some of the vitamins and minerals that are present in milk. And some more that we have here is the milk is an outstanding source of most nutrients except iron and vitamin C. So the milk lacks iron and vitamin C, which are present in very small amounts. Also, vitamin D is added to almost all milk sold today. So even vitamin D is something that lacks in milk, so that is added. So moving on with some of the flavor components. So the compounds that contribute to the overall flavor profile of milk are varied and complex. So they include some of the flavor components are volatile organic compounds, notably aldehydes, ketones, acids, and the actual compounds in a particular milk sample are determined by previous treatment of the milk. So there are certain treatments of milk through which the main flavor of the milk gets decided. Some of the methods can be heating, fermentation, and storage. And some of other flavor components can be lipase action on lipids, as well as oxidative changes during storage, which releases butyric acid and other fatty acids that ultimately have a strong influence on flavor. So these are some of the components other than heating, fermentation. We have the lipase action on lipids that is happening while heating and fermentation. Also oxidative changes that takes place during storage, which releases butyric acid and other fatty acids that influence the flavor of the milk. So let's just keep this video till here. I'll be back with another video starting from this point where I left today. So thank you for watching this video and stay tuned for more.